Hi everyone, welcome to the next lecture in our bit manipulation series. So till now we have discussed some basic problems on bits. Okay, we have discussed find ith bit, clear the ith bit. Okay, find RSB, clear the RSB. We have discussed a beautiful algorithm, that is Brian Kernighan algorithm. So a lot of problems we solve using that algorithm, a lot of problems. Okay, and we have worked with characters. So we have discussed converting uppercase to lowercase, lowercase to uppercase. Okay, inverting the case, find the position of that case, the letter. Okay, so if you haven't watched those lectures, I will recommend you, I will highly recommend you to please watch all those lectures. I have uploaded 17-18 lectures on bit manipulation. Okay, please watch them. And from now onwards, we'll work on a lot of good problems. Okay, from now onwards, we'll work on a lot of good problems. So we'll start with XOR. Okay, we'll discuss 10-15 problems on XOR, are really good problems on XOR. So I used to say, if you know XOR, you know bit manipulation. Believe me, I'm repeating it again. If you know XOR, you know bit manipulation. Okay, so it's a very good problem. The problem you are seeing, single number, it's a very good problem on bit manipulation. Okay, and we'll solve each problems with a lot of approaches. We'll start with brute force. Okay, we will continue with better approach. Then we will go through optimal approach. Okay, and let's start with the first problem. Okay, let's start with the first problem. So this is our first problem, that is single number. Okay, and what does the problem states? It states that given a non-empty array of integer nums where every element appears twice except for one. Every element appeared twice except for one. Find that single one. Okay, now you know why it named as single number. Okay, it is single. So you must implement a solution with the linear runtime complexity, and this is we will see. Okay, we'll start with our brute force. So now this is our array. Okay, all the numbers in couple form, right? All the numbers appears twice. Only one is alone, like you and like me. Okay, so in this array, one appears twice, two appears twice, four is single, like you, like me. Okay, so we need to find that single one. Okay, so let's discuss this problem. Okay, so this is our problem statement, and we have given the array. Okay, so four is appearing twice here, so it is not answer. Okay, two is appearing twice, it is not answer. One is appearing only once, so it is our answer. Okay, so this is our array input, and one will be our output. Correct. Now, how to approach this? So if I start with brute force approach, so what I can do, if I start this, if I start from here, okay, I'll check for four. Okay, I'll check the whole array. So four is appearing twice, so it is not our answer. Okay, I'll check for two is appearing twice, so it is also not our answer. I'll check for again two, so two is appearing twice, it is not our answer. I'll check for one. Okay, so one, check throughout the array, so one is not present anywhere else. Okay, so the count of one is only one. That means it is our answer. So as soon as we get our answer, we will return it from here. Okay, no need to check further. So let's start how we can solve this. Okay, so what I can do, I can take a loop to traverse each element. Okay, all these elements. So if I take a loop, I'm writing the pseudocode for it. Okay, it's the easy one. So if I take the loop, let's say 0 till my this array size. Okay, it's array size. So now my eye is here, okay, from this position, and I'll keep on checking in all the elements until my array get exhausted. Okay, so I will again take a loop, so let's say ij, take naming convention better. Okay, I'm taking ij, take a better naming convention. So I'll start from where, every time I will check for whole array. Okay, every time I will check for whole array, so I will start from 0 itself. Okay, from first position itself. So I will run till my array size. Okay, and how to compare the occurrences. So initially what will the occurrence when I'm at current position? Okay, let me erase this. When I am here, what is the occurrence of this? Initially it will be 0. Okay, so take one variable. Let's take count. So initially it will be 0. Okay, and while traversing, increment the count. Okay, so how I can compare? I can compare this current element with the traversed element. Okay, so my current element will be array of I. Okay, and I'll compare it with the traverse element. So we are traversing here. Okay, so array of j. Okay, if it is equal, what I will do? I will increment my count. Correct. Now after traversing this once. Okay, so let's say I'm here. I have traversed all these. So here my count of 4 will be 2. Correct. Now here I will traverse from here 2. So my count of 2 will be 2. Correct. When I came here, okay, let me draw this. When I will be here, what I will do? I'll keep traversing it. After traversing this loop. Okay. After traversing this loop. So when I'm at this position, okay, and I'll keep checking. On the complete array. So now my count value will be 1. Okay. So after traversing it, my count value will be 1. So do I need to check further? No, right? So now here I will check for one more condition. Okay. So after this loop, I will check if my count is 1, then I will simply return this. Okay, I will simply return. What I will return? I will return that element. Okay. So it is nothing but array of I. Correct. So check in the problem if they are asking for index or element. Okay, so if they are asking for element, just return array of I. If they are asking for index, just return I. Right. So this is our brute force approach. Okay, I hope you can code it. Right, you can code it. So I have almost coded it. Okay, so this is our brute force approach. How much time it will take? So we have running a one loop here. Okay, so it will take how much time? It will take order of n time. I'm running one more loop. Here. So it is also taking order of n time. Correct. So total time will be order of n into n. That is nothing but order of n square. Okay, this will be our time complexity. Now what is our space complexity? So we are using one variable only, right? We are using this count variable only. So my space complexity will be order of 1. Okay, but we need to optimize this. Okay, order of n square time complexity is a lot. Okay, so we need to optimize this. So what can be a better approach? See, if you're solving a problem, okay, start with the brute force. So majority of the time your brute force will be order of n cube or order of n square. Okay, just try to take 2 loops, 3 loops. Okay, try to solve using 2 loops. If not possible, try to take using 3 loops. Okay, and then try to optimize it. Okay, so the second approach should be using map or using set. Okay, so using map, the time complexity is reduced, but the space complexity increases. Okay, it takes some space. Same with set also. So how we can use map in our problem? Okay, let's use map. So in map, if we talk about C++, in C++ we have unordered map and ordered map. Okay, we generally call it as map. So unordered map, in unordered map, it doesn't store data in sorted order. Okay, doesn't store data in sorted order. Map stores data in sorted order. Okay, and what is the time complexity of unordered map? So the time complexity unordered map takes is order of n for most of the cases, but in worst case it can go till order of n square. Okay, when a lot of collisions are there. And in case of ordered map, the time complexity is order of n log n for each case. Okay, because every time sorting is maintained. Okay, so we will use unordered map for our problem. Why? Because we don't want data to be in sorted order. Okay, we just want our count. We just want our element and count. Okay, so we don't need to use map. Okay, we don't need to use n log n operation. So we will use unordered map for it. Okay, how we can use unordered map? So let's take our example. Let's say we have an array which contains 3, 2, 1, 2, 1, 4, 4. Okay, let's take this example. So here 3 is occurring only once. Okay, 2 is occurring twice, 1 is occurring twice, 4 is occurring twice. Okay, so how we can use map? What's my idea is I want to traverse the array. Okay, I want to traverse the array and put all the elements and its count in map. Okay, so I hope you know how to use map. So map looks like this. Okay, not that bad, but it looks like this. Okay, it has some key and some value. Okay, in our case, what I want to store? I want to store element as well as its count. Okay, so in our case, the element will be our key and the count will be our value. Okay, and I will keep storing the element in our key and its count. So let's start from here. Let's start traversing. So I am here. Okay, I will check 3. 3 is not in our map, right? So store 3 with its occurrence. So it is 1. Okay, now I will move forward. Okay, now I will be here. So check 2. 2 is not in our map. Okay, so put 2 in the map with its occurrence 1. Okay, now again move forward. Move forward. 1. 1 is not there in our map. So store 1 with its occurrence 1. Okay, now move forward. 2. 2 is there in our map. Okay, so increment its count. Now move forward. 1. 1 is there in our map. Okay, so increment count. Move forward. 4. 4 is not there in our map. So store 4 with its count. Okay, move forward. Now 4 is there. So update its count. Okay, again move forward. Now we have exhausted the array. Okay, so my map contains all the elements with its count. Okay, so if you see 4 contains 2, 1 is occurring twice, 2 is occurring twice, 3 is occurring once. Okay, so this operation traversing the array, how much time it will take? It will take order of n time. Okay, and now what I want to do, I want to traverse this map also. I want to traverse this map also to find which element has one occurrence. Okay, so let's traverse this map also. Okay, so check 4. Is the count of 4 is 1? No. Again check. Is the count of 1 is 1? No. Check if the count of 2 is 2. No. Check count of 3 is 1. Yes. So return 3. Okay, return 3. So this will also take how much time? It will also take order of n time. Okay, let me write it here. To traverse the array, it will take order of n time, and to traverse the map, it will take order of n time. Okay, it will take order of n by 2, but we are now talking about amortized. Okay, we are talking about amortized time and space complexity. Okay, usually we talk about time complexity and space complexity in amortized form. Okay, if you don't know what is amortized, just read it in the Google. Okay, search in the Google and read any article, you will get it. So what we used to do in amortized, basically we don't consider the constant. Okay, so n by 2 is same as n. Okay, 2 into n is also same as n. Okay, So we don't consider constant in amortized time and space complexity. So it will take order of n time to traverse the array and order of n time to traverse the map. So total time complexity will be 2 order of n. Okay, and again we are talking about amortized, so it will be order of n only. Okay, we're doing 2 passes of order of n and order of n. Okay, now what will be my space complexity? So my space complexity will be order of n. Okay, why? Because we are taking a map. Okay, so this is a map, so it is taking some space. Okay, again it will take less than n time, but we are talking about amortize. Okay, so amortize, it will take order of n space. Now it is taking order of n time complexity and order of n space. Okay, it is better than previous, but we want to further optimize it. Okay, so what if I reduce this space complexity, and what if I don't do 2 passes? What if I do only 1 pass? What if I do only 1 pass? Can we solve it using this, only this time complexity? Can we solve? Okay, so there we have one more approach. We have one more approach, that is using bit manipulation. Okay, so our third approach is using bit manipulation. So we have learned 5 6 operators, right? We have learned bitwise AND, bitwise OR, bitwise XOR, okay, left shift, right shift. So bit manipulation is all about these operators only. Okay, if you know where to use which operator, your mostly part is sorted. Okay, and as I told you in the beginning of this lecture, if you know XOR, if you know how to use XOR, 90% of the part is done. If you know how to use XOR, you know 90% of the bit manipulation. Okay, so we will use this powerful operator. Okay, throughout a lot of problems. Okay, so in this approach also we will use this XOR. We'll use this XOR. Now, if you don't know how XOR works, so let me remind you quickly. So XOR says that same pay 0, different pay 1. Just repeat after me. Same pay 0, different pay 1. That's all you need to learn about it. Okay, so this is in Hindi, right? This is in Hindi. So if you don't know Hindi, what does it means? It means that the result will be 0 if my operands are same, and the result will be 1 if my operands are different. Okay, so XOR take 2 operands, right? It takes 2 operands, and the result will be 0 if the operands are same. The result will be 1 if the operands are different. Okay, and in books it is written like 1 XOR 0 will be 1. Okay, 0 XOR 1 will be 1, 0 XOR 0 will be 0, 1 XOR 1 will be 1. Okay, so these four lines written in book. Okay, and I simplified it to these two: same pay 0, different pay 1. Okay, it means that if both the operators are same, then it will be 0, and if both the operators are different, then the output will be 1. Okay, the same we will use for this problem also, and in future problems also. Okay, so I told you the properties of XOR, okay, in the first lecture itself and now also. So for the next 10-15 problems, just keep in mind about it. Okay, keep in mind that XOR is so powerful. If you know XOR, you know bit manipulation. If you know XOR, you know bit manipulation. Okay, so now move back to our problem. What was our problem? So we have given the array, okay, and it had 1 4 4 3 3 2 2, right? So we had numbers in couples, okay, and only one was single. Only one was single. I'm talking about the problem. Okay, so how can we use our XOR? How can we use our XOR? So what what if I keep doing XOR of all these elements? What if I keep doing XOR of all these elements? Okay, let me write what I'm saying. So if I do 1 XOR 4, okay, and if I do 1 XOR 4 XOR 4 XOR 3 XOR 3 XOR 2 XOR 2, okay, what is going to be result? What do you think? What is going to be the result? Okay, so I told you same pay 0, different pay 1. Okay, so find the similar ones. So I told you how does XOR works? Same pay 0, different pay 1. Okay, so in this, try to find out the similar one. So here 4 XOR 4, it will cancel out each other. Okay, 3 XOR 3, it will cancel out each other. 2 XOR 2, it will cancel out each other. Okay, so now we will left with what? 1. Okay, let me write it. So 4 XOR 4 will give me 0. Okay, 3 XOR 3 will give me 0. Okay, 2 XOR 2 will give me 0. Okay, now these same pay 0. So this will also 0. Okay, now see this same pay 0. This will also cancel out each other. Now 1 XOR 0 will be 1 only. Okay, will be 1 only. So if there is any number, if you do XOR with 0, it will give me the same number. How? Let's see. Let's see. So let's say if I do XOR of 5 XOR 0. So 5 can be written as 1 0 1. Okay, and this will be 0. If you do XOR of it, what will happen? This will be 1, this will be 0, this will be 1. Okay, so the same number will be written. Okay, so if you do XOR of any number with 0, it will give me that number only. Okay, so that's how we can solve this problem using bit manipulation. Okay, so what I need to do, I'm just doing XOR of all the numbers, all the elements in our array. Okay, so this will cancel out each other, this will cancel out each other, this will cancel out each other. Okay, and remaining will be our single number. So it is very simple, right? We need to do only one pass. Okay, I'm writing the pseudocode for it. So if I start from 0, I will run till array size. Okay, and simply what I will do, let's take one variable. Okay, let's take result. So initially it will be 0. So if I do result XOR with my number, okay, so it will keep doing this 0 XOR 4, then 4, then 3, then 3, then 2, then 2, then 1. Okay, and at the end we will get the number which is single. Okay, so at the end we will get this number. Okay, so now I hope you learned how XOR is working. Okay, so XOR is this much only. If you understand this carefully, you will do a lot of problems in XOR by yourself. Okay, so this is our third approach. Now what will be the time and space complexity? So the time complexity of this approach will be, we are traversing the array once, so it will be order of n only. Okay, and we are taking one variable result, so it is nothing but constant, right? So the space complexity will be order of 1 only. Okay, so we have discussed 3 approaches. We started with the brute force approach by taking 2 loops. Okay, so the time complexity was order of n square, space complexity was order of 1. Okay, now next we move to the map approach. Okay, map took order of n time plus order of n time, and the space complexity was order of n. Okay, and at last we solved using bit manipulation. Okay, using XOR. So it took order of n time as well as order of 1 space. Okay, this is nothing but time complexity and this is space complexity. Okay, so that's how you should proceed with the problem. Okay, in future problems also we'll start with brute force, then we'll solve using better approach, then we'll solve using optimal approach. Okay, there are 2-3 variations of this problem. We'll solve all of them. Okay, so this is all about this problem, and I hope you understood this problem. So if you understood this problem carefully, the next 10-15 problems will be very easy for you. I'm giving guarantee to you. Okay, so if you understood this problem carefully, next problems will be very easy. Okay, just keep focus on this XOR. Okay, keep focus on this XOR. So if you solve any problem using XOR, try to solve it. Okay, so that's all about this problem, and let's move forward to next problem.